Pozdrav svima, s nama je danas Mateo Koko iz Dassault Systema i on će nam predstaviti 3DEXPERIENCE platformu za školstvo, edukacijske ustanove, profesore i studente. Hvala vam što ste ovdje i za sva pitanja slobodno pišite i na kraju ćemo imati sesiju gdje ćete imati priliku postaviti sve što vas zanima. Mateo, you can start.
Okay, dober dan.
Dober dan.
Thank you for such a nice introduction, but I haven't understood anything. In any case, what I would like to do today is just to share with you what are the specific direction that the Dassault Systèmes is taking in the world of education, and what is our main, let's say, purpose. So to drive the engineering education using a virtual twin and leveraging this virtual twin for building what is the workforce of the future. So first of all, let me introduce myself. I'm Mateo Koko. I'm the education leader of the Dassault Systèmes for EUROMED. So I keep the relationship with the universities, research center and competence center in all the region that include Italy, Adria regions, Balkans, Israel, Turkey, Bulgaria, Romania. And basically my main objective, my main target is to have more and more students adopting our solution. So I don't know if you know Dassault Systèmes. Basically, Dassault Systèmes, it's a huge multinational French company. We like to define us as a scientific company because we strongly believe that the virtual world extends the real world. What does it mean? It means that we strongly believe that everything is around sustainable innovation, and this virtual world can provide to our customer solution for testing, analyze, and model their product before to realize them. This means that if you are able to move most of the realization process of a product in virtual, we can save a lot of money, and also we are very green because we don't produce a prototype that then they will be waste. We are 20,000 passionate people. Of course, we have a very strong long-term vision because we have 4 million of revenue, and we are very solid company, mainly in front of our customer that think about us, that we are reliable for implementing their let's say technological and strategic IT vision. We have a lot of partners around the world, and CAD/CAM is one of them, and it's one of the best also that I have in the region, because with them, since I arrived in Dassault 5 years ago, we started a journey with the universities that brought us to develop a lot of interesting initiatives that later on I will present to you. And of course, as we are a solid company and a reliable company, we have a lot of customers that trust us, and they believe that with our solution they can move forward with their development, their overall development. Of course, we are, as I told you, a multinational company. We have a worldwide presence with 3 main offices. The headquarters is in Paris, and we have other 2 branches in Boston and Shanghai. What is our history? Basically, the Dassault Systèmes, it's 40 years that is on the market, and back then in the early 19th, we were a technological spin-off. We born as a technological spin-off of Dassault Aviation for making the 3D modeling technology, the CAD, computer-aided design. Moving over the years and taking the challenges of the industries, mainly of the aerospace and defense industry, we noticed that in 1989 the challenge was to provide to the designers a complete assembly of a product. And when we are talking about an airplane, we are talking of thousands of parts. And believe me, in 1989, looking in a screen, an assembly done of thousands of parts was really a challenge, because you would have need a servers big like a washing machine. So we found we addressed our development in order to develop different strategies for lightweight 3D modeling. Then we understood also with the evolution of the IT that managing 3D models was not enough anymore. So we moved to the concept of product lifecycle management. So managing not only 3D model, but all the information related to the complete product development process. In 2012, we launched our core product that now is 3DEXPERIENCE, which was an holistic platform that addressed the complete new product development process end-to-end, from the very beginning, so from the concepting phase, until arriving to the, let's say, selling, post-selling, and maintenance. This was one of the first biggest step in our change of paradigm towards the new challenges of Industry 4.0. And last year, we launched our new ambition, and the new ambition is to develop the virtual twin experience of human. So this means from moving from the non-organic to the organic. What does it mean? It means, put together all the experience that we build in the mechanical sector and bring all this experience in the biomedical sector, in the life science, in order to provide to our customer new solution and new experience for addressing human challenges related to medicine. Basically, our ambition is to provide personal medicine and personal solution for surgery and so on. So I think there is no much to discuss about this slide. As I told you, we have a lot of customers all around the world. Basically, our core industry are transportation and mobility and aerospace and defense. We can say that the 90% of the cars that you can see in the street are made by at least a component is made by a Dassault Systèmes software, and every 2.5 seconds is taking off a plane with an engine designed with the Dassault Systèmes solution. So you understand how is our footprint in these industries. But now we are facing also new challenges in the, as I told you, in the life science, in the construction and the architecture sector, and also we have a strong footprint also in home lifestyles and high tech. Say that we have also a strong footprint in your regions, thanks to the work that CAD/CAM is doing locally. These are all the companies, high-level company that are using our solution, and they are basically what they are doing. They are looking in the market for people skilled and trained on our solution. So what I would like to tell you today is basically that our solution and our footprint in industry is driving this kind of research of new talented people that are trained on 3DEXPERIENCE and on the solution. And this means that if you are trained on our solution, your employability grow. And for And as you can see in this slide, I reported just some advertising on LinkedIn, but also on our website of academia. If you, I don't know if you ever seen it, on our website we have a portal called the Job Place, in which you can find only the job related to the Dassault System. And here you can see the type of company that are looking for people skilled with the Dassault System solution competencies, like Airbus, PSA, Alstom, Tesla, and so on. As I told you, we have a strong footprint in the industry, but thanks to the work that I'm doing and also with in collaboration with partners like CAD-CAM, we have also a strong footprint in the academia market. Basically, we have today 5 million students per year that are using our technologies, 50,000 academic institutions that are adopting the Dassault System solution for providing lecture to their students, and we are trying to build a network of let's say competence center and laboratories all over university for creating a community of talented people and experts that it's a pool for us of people that can be taken and proposed to our customer, or that can be hired by us. As I told you, we have this strong footprint, and also locally in my region, we have developed many initiatives in different universities. For example, we have the faculty of Rijeka, the faculty of Zagreb, the university in Belgrade, and so on. So we develop a different initiative, and we are running different projects in which we are involving students from different levels, of course, in different tasks. And the only purpose, of course, is to develop competencies and knowledge on technology, on our technology. And say that this is basically what I do every day. So for me, what is my target in Dassault is to, first of all, develop in the new generation the skill of the future, because they are more and more needed in the market, and it's very difficult to find people and students and profile that have the right skills. Then, of course, I work also for the lifelong learning, because it's important not only address the university students, but also to develop people in their career, in the job career, because we need always to reskill and upskill also the employee of the company. Of course, I do so leveraging the experience-based learning, so putting in the center of the education, put in the center of the didactics the fact that there is an experience, they have to solve problems, they have to face issues. So, and in order to have them basically making mistake, because only making mistake in virtual, they can learn without wasting, real product. And of course, once we addressed all these 3 points, we will have in few years, maybe 2-3 years, a global network of talent that we can leverage basically for covering all the needs of the company that are our customers. After this short introduction, what I would like to do today is to explain you what is, in general, and very fast, very quick, what is the 3D experience. And then I would like to show you a couple of examples that shows how the 3D experience and the virtual twin can be used in the education process. So I will launch a video about 3D experience.
Hello, I'm Charles. I'm a Dassault Systems engineer. I work here doing stuff like this, and it's awesome. Today I've got approximately 2 minutes to tell you about our 3D Experience platform and show you how it's amazing for your 3D projects. So, let's get to the basics. What is the 3D Experience platform? Explanation. It's a platform that gives you access to a catalog of applications or apps, like the kids say these days. These apps allow you to design, simulate, inform, and collaborate on a project. Got it? Good. Let's imagine you want to build a hoverboard. There's going to be more than one person working on your project. For example, engineer, programmer, marketer, mechanical designer. Before, you used to work like this. No more, now that you can work on a 3D Experience platform. But yeah, the platform looks like this. It's pretty cool. First things first, you need to create your personalized dashboard. It's your own picked out working environment. Then you can invite your friends and colleagues to hang out. Kind of like a video game party. There we go. Except it's for work. From there, you can finally begin your working journey using the most incredible toolbox ever created. And inside, you will find this, or this, or this. But rather, multiple apps designed to help you collaborate on the project at hand. Every job position receives their own personalized package and therefore applications. For example, if you're an engineer, like this guy, you'll find all the apps you need to virtually simulate your hoverboard. And of course, you'll have access to all the necessary collaborative applications that make it feel as if you're in the same room without having to be in the same room. Tourism. You can work on your project from anywhere, on any device. Got it? Good. With the 3D Experience, everything is stored on the cloud. Not this cloud, this cloud. Which means that you can never lose anything, and anyone can access the latest version of a project at any time in total security. Which means you'll never have to listen to this sentence again. Yeah, which version is a good version? Is it master good final, or final master good? It also means that you can share what you want with who you want and keep what you want to keep private, private. Thanks to these project management tools, each individual can share their agendas and progress. And because Dassault Systems is present in every industry, hell, wonderful product. Where can I sign to invest? The 3D Experience platform is the solution you'll use for the rest of your career. So you might as well start using it now. Look at all the business opportunities it presents. Got it? Good. You want to create your own design, challenge yourself? Click on this link right here to subscribe. Right there. You just click it. Take your mouse, go over, and you just stick right there. Good job. Proud of you. This was fun.
Okay, I hope the sounds was good also on your side. Basically, what is a 3D experience? It's a technology, it's a tool, it's a software that allows you to transform your idea in a real product. But let's do a step back and understanding what there is in the middle of this, of this transformation. Because when you are talking on transforming an idea to a product, in the middle we have a process, which is basically the product development process. Not always is it just an idea, but sometimes we have a request. This means that we have to change something that already exists, but the process is almost the same. And in this process, we have a lot of actors involved, a lot of basically of data, a lot of information, and a lot of software involved. I don't know if you run project like Formula Sci or Moto Student, because you address almost the same process. But what I have experienced all over the year, mainly also with companies, is that each company has a lot of different standalone solutions for addressing specific part of the product development process. And if we come to the new challenges of Industry 4.0 related to time to market, effectiveness, optimization, you can understand that if we have this situation in our company or in our project, it's not optimal for basically for be effective or efficient, because each software has its own model and his own standard format. And if we want to move and use another software, we have to export in a standard format, re-import in another software, losing, of course, a lot of information related, for example, of feature or specific peculiarities of this software. And also we don't have digital continuity, because all of these tools are personal tools, not tools for collaborating. And what I have experienced in the companies, and I was shocked the first time, is that all the process mainly is addressed by Excel, a lot of Excel, and no one of them is equal to another. So different people, different Excel, different data, no consistency, equal a lot of mess. So for these reasons, Dassault Systèmes put in place a strategy. Everybody knows us for mainly our software CAD, SolidWorks and CATIA, but over the year, Dassault Systèmes acquired all this company. In 15 years, we acquired all this company. Back then, each company was a software company, of course. They were at the top of the development of their product. We acquired Abacus for structural simulation. We acquired Matrix One for data management. We acquired the Exalid, that it was the former AltaVista for crawling, engineering, and search. We acquired, for example, RTT, which was the rendering engine for RTT is the company. Okay, they were making a rendering engine that Audi is using for their advertising, and so on. We bought a lot of simulation software also for fluid dynamics. For example, Xfluid Exa. They are software for fluid dynamics in terms of lattice Boltzmann execution, and so on and so on and so on. The last acquisition was Medidata for managing clinical data of patients in the hospital. So this was also addressing which was our first vision about the digital twin of human. And what we have done, basically, we rebranded them with our name. So Simulia, we're covering Abacus, Enovia, we're covering the data management, and so on, 3DEXPERIENCE for the rendering, and so on and so on. And basically, we were at the same situation that I showed you before. We had a lot of different software standalone, the CAD for the design, a lot of KI simulation for analysis, Delmia for computer-aided process planning and machining and the manufacturing part, but none of them, apart from some integration, were integrated, basically. And in order to address the incredible vision of Dassault, what we have done, we put everything on a unique database, and we create the 3DEXPERIENCE. The 3DEXPERIENCE, it's a unique platform that includes all the functionalities of this different software, and it's based on a database. So we are not talking anymore about file, but about data. And what is the advantages? That all the people can share and look the same data at the same time, so they can collaborate in their project, and also they can give feedback to the project, to the process, in order basically to improve continuously this process. Only with the feedback we can improve the process. And if we have continuous feedback, we can continuously improve the process. But if we don't have feedback, we don't know from where we have to start for improving something. So just for recap a little bit, so the Dassault Systèmes moved from different standalone software, the CAD, the KI, each one with its user interface, its data model, its security policy, and so on. And which was basically the vision was to say, okay, the CAD, the KI, all these software are leveraging on the 3D model of the product. So why we don't put at the common in a common environment the 3D model. All the people that need to work on the 3D model, they look at the same data. So this was the purpose of building the 3D experience, which is a unique platform with a unique database, a unique interface based on a unique data model that ensure the digital continuity in the process. Just quickly, I would like to dry run what are the functionalities that we have. Inside there are collaboration and data management tools, so you can manage bill of material, as well as the platform can be used as a portal, so you can build up community and dashboard. And also there is a tool of project management. We put inside all the functionalities coming from CATIA, from all our tool of computer-aided style, so it's possible to do also sketching or clay surface. And also we put together the functionalities of Dimola, so for doing, let's say, the system engineering simulation, so for modeling the system, the subsystem of a product, and understanding how are exchanged the variable and the signal between the different systems. And this is very important, mainly now, because in the market we are looking the growing complexity of the products. Today we have more and more products that are mechatronics and not just mechanics. If we think at the car 40 years ago, basically it was 100% only mechanic. Now we have thousands and thousands row of coding inside also a simple and small car. Then we put inside also all the functionalities for construction and for addressing the BIM, building information modeling. So you can model all the things for civil engineering, for territories, and so on. We have also a tool for visual coding and for building complex shapes. This is the competitor of Grasshopper and Rhino, the integration of Grasshopper and Rhino. But the advantages that you have here is that it's everything in a unique environment, and you can leverage this geometry afterwards in CATIA, for example. Things that you cannot do with Rhino and Grasshopper when you have finished the concept design. Then we have tools for simulation, product simulation, basically thermal, structural, and the fluidodynamics. We have tools for rendering inside, and we cover the whole process of additive manufacturing, from the topological optimization until arriving to the stratification and to the analysis of the defect during the stratification caused or triggered by the melting, the metal melting due by the laser. We have also, of course, process simulation tools for computer-aided machining, computer-aided process planning, robotics. We can simulate assembly lines and robots, mainly for simulating all the assembly or manufacturing process. And last but not least, basically, if the data are available, can be shared towards the dashboard in any aggregation with graph or with widgets and so on. So just to recap, look into this schema, to this process. The 3D experience, it's covering the whole scenario. So what?
Okay, Mateo Dragana is here. We are facing some video and sound problem with the sound.
Okay, can you hear me?
Yeah, I think it is some connection problem or whatever, but there is no sound and the video is stopping and breaking. So.
Okay, do you want me to replay the video or?
You can try, but we can skip that if.
Okay, just the video was just to show you that what is our main purpose. It's experience the product before it exists. This is our main purpose: is to leverage the virtual twin as a key enabler of the sustainable innovation, to model and understand the real world, of course, define and evaluate the future scenario, and of course implement right the first time. This is the purpose to use a virtual twin, and you can see that we can cover all the industries, from modeling the molecules, the molecular interaction, simulating the factories, simulating the city or the plant. So we can build the virtual twins. We have the capability with the 3DEXPERIENCE platform to build virtual twins. And for me, that I'm basically in the education environment, education market, I see two potentialities: the use of virtual twin for being taught, so teaching the virtual twin, so how to make it, and teaching with the virtual twin. And what I would like to do now is to show you a case study that we made in some years ago in EUROMED about a humanoid robot. I will be very fast of this. Basically, this was an experiment that we made for do the training of our interns. When we started this project, everyone told us that it was impossible doing this in 6 months. We did it, but I didn't tell this to my intern. I say, okay, we have to do so, and we have to finish in 6 months. And my MD was saying to me, my boss was saying to me, Matteo, this is impossible. But I didn't tell them. And basically, we started this journey with the purpose of course, demonstrate the digital continuity using the platform, so using a single environment for collaborating. For doing this project, we hired in internship three engineers coming from Politecnico di Milano. One was a mechanical engineer, another one was a material engineer, another one was a computer science engineer. So 3 different backgrounds working all together on the same project, on the same data, on the same platform. But not on the same, of course, not on the same task. So everyone was, doing its own job in the platform and collaborating with the others on the same data. Then the purpose was to demonstrate the effectiveness of the virtual twin. So as soon as we can develop our product in virtual, we can do the validation of some requirements early in the development process before to build the real prototype. And this is the real advantages of leveraging the virtual twin, because if we can build a behavioral model, things that we can do on the 3D experience of our product, then we can do all the tests on the virtual side, avoiding, of course, to product the real prototype and being sure that when we produce the first prototype, it's right the first time. And of course, working in a managed environment like the platform means having all the data under control. This means that the revision, versioning, all the different model, the branches, all the different development, the variants are managed under the platform. This means that when we have to do further evolution of our product, will be really easy. Really easy, because all the data are organized and managed in a proper way. And we don't need to lose time to find them, because they are managed by the platform and they are consistent with the maturity that they have in that time. So why we use Poppy, basically? We use Poppy because I know it seems a toy, but it's not a toy. This robot costs 10k euro. And I mean, inside there is a complexity related to the control software, to the hardware, to the electrical, to the mechanical part, and so on. And the most interesting things was that we asked the budget for buying Poppy, and the manager came to us and said, next year we do the project on a real car because it costs the same. Say that we used the Poppy because it was the perfect sample for putting in place an example of mechatronic design. So for doing so, we used the methodology that is coming from aerospace and defense, called system engineering. So we built, first of all, we studied the requirement, then we defined the functional analysis, then we did the logical architecture definition. So we divided the robot in system and subsystem, and we defined all the interaction between the different subsystems, defining in the subsystem with equation the behavior. This is really important. So when we are talking about a virtual twin, we are not talking about just an assembly or a digital mockup. I'm talking of a 3D model that inside has the behavior. So engineering equation that define how the product is behaving, even in real. And of course, then we did the design in 3D. Okay, this is the standards coming from aerospace and defense. So just for telling you that we didn't reinvent the wheel. We have always to start from something that it's standard and it's consolidated. And these are all the different scenarios that we put in place about collaboration and planning, system engineering, requirement validation. So here we did the topological optimization of the different parts. Then we integrated an external CAD, because for the platform the CAD is a commodity, so you can integrate each CAD you want. Then we did the assembly, the simulation of the assembly, and then we have seen also the robot in virtual reality. This just for showing you that all these points were addressed on the platform, and the platform ensure the digital continuity and the fact that if you want to make a change, you can easily understand what is the impact of your change, because you have all your data under control and all your data are available. So the first step was to build as I told you, the behavioral model. So here you can see that we put all the equation in the system and subsystem for simulating the hand following the trajectories. And I mean, this is a real work, and it was really tough to develop all the software and all the let's say the matrix of positioning, the position for defining the trajectory. Then once we have done the design, one of the initial requirement was to reduce the weight of the robot. So inside the platform, we have all the functionalities for doing the topological optimization in order to define shapes that are good for example, for additive manufacturing. And with this process, we were able to reduce the weight of 10%, or the weight was reduced of 15%, and we increased the stiffness of 10%. So you can easily understand that inside the platform, we can address all the process, starting from doing the topological optimization, reconstructing the surfaces, and then validating through the structural analysis. One of the advantages of using the platform is also to being able to compare different analyses, looking to different basically to different KPI related to the analysis, in order to choose the best one. Then when we bought the Poppy came to our office in this box, and it was basically without any instruction. So what we have done, always in the platform, we defined the assembly in virtual. So we defined all the different steps of assembly, always starting from the 3D model. We decomposed all the model, identifying all the station. Let's say, imagining that we were in a factory with a different, operation to be done in different, table of the factory, even if we need so in our office, and we decomposed the process in different steps. And then we at the end we had all the documentation for assembly it. And at the end, what we have done, we took the real Poppy and we connected it with the virtual one in order to have the real virtual twin, and validating that the real one is behaving like the virtual one. So in this case, we are able to register and get all the values of the variables in terms of torque, strength, temperature, rotation, and so on, directly from the virtual one, without putting any sensor on the real one. So this is an example, but in the companies, mainly in the companies that are line builder, so they build the line for assembly or for manufacturing, they do this process all the time, because they cannot risk to put in production a robot that is not tested virtually before. Because if the robot does something that has not been tested before, it's very risk for security. There are a lot of risks for security, and it's dangerous for all the factory, because I don't know if you have ever seen a robot that you are not sure that what is going to do. It's no one is going to commit on that. And okay, so this is the video. I don't know if you are able to see it, of our intern playing on my desk with the robot, and we put in place all the different scenarios. You can see how the virtual is behaving like the real one. And for example, this is the inverse kinematic. So we are registering the movement and then replicating it. And you see the accuracy of the virtual one. So just to recap, we used the virtual twin for teaching to our intern how to learn, how to work with 3DEXPERIENCE. And we started from, of course, from the designing, the virtual one. Then, of course, we virtually validated the 3D model, and we built the real one. And gathering basically the data from the field, we were able to learn how to improve the design of our virtual model, of our project. Because basically, when we were taking the strength, the torque, the trajectory, and all this data, we were able to understand which is the maximum force to put in the actuators. So when you know what is the maximum force that you can put on an actuator or on a component, then you can redesign accordingly all the components. And this was an example of how to build in our intern the skill needed for the future. And now, I mean, there were three guys. One of them was hired by Dassault Systèmes and is still working with us, and now is the best technical guys we have. The other two, they were hired by our competitor, unfortunately, and they are, they are working for Autodesk. But this experience was good for them because at the end it was really, having a value added for their career. And I would like to suggest also this to you. I mean, try to understand what are the skills needed for the future, and don't be shy and go straight towards the realization of your career. Another example that I would like to share with you, it's the collaboration that we have with the motorcycle factory of Politecnico. So this is a team of students that we have in Politecnico di Milano. I'm based in Milano, so they are very near to my office, so I'm working very, very close to them. They are a student team that they are participating to the Moto Student. I don't know if you know, this is a competition between different universities about motorcycle. The counterpart for car, there is the Shell Marathon, we have Formula SAE, and so on. So what we did with them, they were basically a PTC Creo excited user. And when I met them, I say you have to throw out the PTC because it's not the right tools that you need. They were really skeptical. And I told to them, so let's identify what are the main issues that you have today, and I will show you how the platform can solve them. So of course, as a student team, they were managing all the data in a shared folder like Google Drive and Dropbox. But when you manage data on Google Drive and Dropbox, of course, you don't manage the versioning and the revision. You don't know who is working on that. You generate a lot of different names. You create different conflict copy of your document because I open it and then I forgot to close it and someone else is working on it. Then also the hierarchical structure of the team is not addressed in the tools that they were using, because it's not possible to define a leader, an owner, or or an author or a pro or a designer in the CAD. The CAD is a personal it's a personal tool. So PTC Creo was a personal tool for them. So each one was the master of the CAD. And also for them was not possible to work in concurrent engineering and simultaneous engineering, because basically they cannot work on the same model at the same time, because if someone opened the model, nobody can work on it. So they had a lot of problem of access to the information. So what we have done with them, first of all, we took the motorcycle and we imported it on the platform. We reorganized the assembly. And we started to, first of all, define who is working on what. Because in the platform, as long as you don't have any more file, but the file are shared to all the people that participate to the project, basically everyone has access at the same time to this assembly. And what we can do is defining different tasks for working for different component of the assembly, but having always the complete vision on the whole assembly. This is in my opinion, the biggest advantages that the platform brings. So what they have done, they create a complete parametric 3D model. Here you can see that changing the parameters, you can change the setup of the motorcycle. Here you have the suspension more wide. Here it's completely compressed. And you know, the setup, it's important mainly when you do the race. Then, of course, they were able with this using the platform, so being based on the database, to manage all the revision and the versioning of the product. Here you can see an example of this piece of the seat. You have the A1, B1, and you see the code is always the same. So you don't need to think anymore about the names, because it's the platform managing the revision and the naming. And you can focus your time not on finding information or to thinking how to put this. This is the final of the final. This is not real the final, it's the very final. And at the end, when you open the final one, is not the final because someone else is modifying it. But in the platform, this is managed because also all the objects live in different maturity state. And if the maturity state it's released, for example, the object is blocked and nobody can work on it. I mean, this is concept related to PLM, but it's just for showing you that when you respect the rule of the PLM of the platform, then you have ensured basically the digital continuity and the consistency of the data. And of course, once the 3D model it's done, then we can move to the analysis part. And everything is done again in the platform. So they did the structural simulation of the chassis. And also they did a topological optimization of the chassis, reducing of 1 kilogram, 15% of the weight. And believe me, on a motorcycle, 1 kilogram in a race, it's a lot, because when you are measured on the top of the top speed, 1 kilogram is making the difference. And they did so with the platform and with the help of course of us. Also, they were able to perform topological optimization of the brake pump. You see here, they were lightweighting all the components in order to reduce the weight, and leveraging also the metal 3D printing, the SLM technology. They made a simulation of the rear suspension in order to understand if which was the maximum shock that could be absorbed by the rear suspension. And basically, this is the final results. And they leveraged also the tools, the functionalities for creating the fairings and the aerodynamics through clay surfaces. So you see how these surfaces are built, are mathematically, let's say, possible because they are made in CATIA. And basically, okay, CATIA is, I mean, CATIA inside the platform, it's the best tool for in the world for surfaces. I'm saying that not because I'm from Dassault, but because it's a fact. if you look to the Guggenheim Museum, double curves surface done by CATIA, and no other 3D modeler is able to do this kind of surfaces mathematically possible. This is the reality. I mean, so they made also the back and the front. Okay, this is the overall assembly of the internal combustion engine. They made also some part of the powertrain, mainly the airbox was their innovation part. I think these photos and model are, I mean, there is intellectual property on that. I don't know if I can show it to you, but I mean, I will trust you that you will not copy the idea. And also there was, I mean, on modeling of the entire intake system from air for cooling the engine. And also, okay, this is how they produced the barrel inside using CNC technology and simulating CNC technology on the platform, and also the FDM 3D printing because it was made of plastic. And also, they were working on two motorcycles. The one was combustion, the other one was electric. And the main effort they have done is for cooling the cooling part of the electric powertrain, modeling a kind of lattice structure inside the cooling for improve the temperature down effect. And I mean, I was impressed because all this basically all this work has been done from just student and with a little bit of support of us, but not too much. And well, finally they made also the fluidodynamic simulation. This is impressive. I mean, it's not the case that they won the last motor student. They were the first team to win the motor student, and then now the new race it's this year in July, and we hope to succeed as well. So just to wrap up everything, and I'm closing. 1 minute. So what we can do together? Of course, we have a lot of experience in building laboratories in the university. Mainly, we are lucky. You are lucky because you have in your country CAD/CAM that is very expert on this, and they are really committed to work on universities. So we, with the help of RIMATS, CAD/CAM, and ITAC, we opened 2 labs in Croatia. Also, other 2 labs in Serbia, in Niš, University of Niš in Belgrade. There is also the video of this opening, and I put this video because to me, remember a very emotional presentation that I have done in Belgrade, because it was amazing. There was a presentation before me of Airbus, a guy from Airbus. He was saying that it was really, he was speaking to the student, and he was saying that it was really strategic to have a collaborative approach in design. And I was, presenting afterwards Poppy and the experience that we have done, and also these guys from the competition of aerospace and defense of the University of Belgrade. It was a really emotional day for me. Very nice, and I'm looking forward to replicate this in your universities, with and also in all the other universities in the EUROMED. And of course, the purpose is to have a lot of laboratory and hub in order to build a huge network for collaboration. I'm working also to support, of course, courses, lecture at the university. This is an example of the not in your country, but in Italy, I'm helping the professor to build the pedagogical material for the motorcycle university of Emilia-Romagna. So this is a course based only on automotive, and we are helping the professor to build all the relevant material for doing the lecture with 3DEXPERIENCE. Now we started from 3D modeling, now we are facing the simulation and the system engineering, and year by year now it's 3 years that we are working together. We are moving forward with the new discipline that to be addressed. Last but not least, it's that we also support student teams. So if you are part of a student team, do not hesitate to contact me, and I will try to support you as much as possible with our software. We have a great experience in Zagreb, also in Maribor, in Politecnico di Milano. Of course, it's my best because it's near to me, and they won. So I'm really proud of them. And also we are working also with the race up of Padua, and I have many others in Rome, in Thessaloniki, in Naples. I mean, I'm sponsoring a lot of team of student, a lot of student team of Formula Science on. And also, if you go in our website of academia, which is okay, it's not anymore, which is this one, we show you straight away. You have a lot of material available. First of all, you can access all the material for trainings available to this link, and you have a lot of okay, the job place that I showed you before. For if you are a student, you can look to the open position requiring Dassault Systèmes software skill, and also we have many. Okay, no, there's not this. Sorry. Oh, it's many ready-to-use material for lecture or for learning. We have the Poppy one, we have a submarine, and so on. And the best one, oh, sorry. The best one is it's about, oh, wait, this. Okay, it's open the project of the year, so you can participate to the contest of PODI 2021. So if you have done a project with our software, you can join the contest. But talking about challenges, we have a complete section about challenges, and you can require the software. Sorry, it's not in my. This is also another challenge. Okay, this is one. We have a complete section in which you can require the software for Formula Student, sustainable innovation. We have many Eco Shell Marathon, and so on. We cover almost all the challenges. If your challenge is not here, you can request to add it. So saying that, let me close this. Whoa. Okay, saying that, my presentation it's done, and I mean, if you have any question, I will be more than happy to answer, or you can find my contacts. I will share with you my contacts, and if you want to contact me to discuss any any curiosity or any things that you come up with this presentation, let me know, and please contact me or contact our reseller CAD-CAM, that I'm sure they will address your request easily. So if you have any question, I'm here.
Hi, Matteo, it's Isidora. I don't have a question, but I just wanted to ask if you agree I can send the link of the video about the platform, because it was hard to hear, it was breaking, so I can put it in the chat so people can see it.
Okay, but do you have the video available or?
It's in YouTube, so
Okay.
people can see it.
You can. Okay, the one. Yeah. Of course, you can share it.
Okay.
Yeah,
Thank you.
I'm really disappointed that this meeting was not physical of course, for the COVID problems, the COVID issue. But I'm really looking forward to come in your countries and visit the universities, speak with the professor physically, looking into the face the student, and comes to the normal business way of business, because I'm really fed up of this virtual meeting that okay, they are good because we avoid a lot of expenses, but sometimes we lose the emotional part.
Okay, then be ready to join us at October time in Belgrade again.
Very happy to hear this. Ciao Dragana.
Ciao. We will let you know and send you all the information. I will also ask if you can share the links for your videos, because
Yeah, I will share the presentation straight away.
That's great.
I mean, I will take it out the part of Moto Student because it's not public, but the rest I can share it.
Sure, thank you.
And you can share with the participant to the call.
Sure.
No question. So everything was clear. I'm happy. Oh, everything was not clear, at least.
Okay, are you sure there is no more questions? Tanya, do you want to close the webinar?
Yeah, I want to thank Mateo that he bring us this perfect and great presentation and explain all possibilities, and thanks all of attendees here. And I think this presentation, it was great, and I hope we will repeat it soon. Thank you, Mateo.
So thank you to you for this opportunity to show what are the initiatives that we are doing in Dassault. It's important to make awareness at all the level, from the student to the professor to the dean and to the ministry at the end.
Yes.
So I wave you in virtually as we used to do with in the.
Really, yeah. Thank you.
When you make an applause in virtual, it's like this. Thank you.
Thank you. Bye-bye.
Bye-bye.
Thank you, Mateo. Bye-bye.
Ciao. If you need any support from my side, do not hesitate. Ciao, ciao.
Ciao.
Ciao.